So hello everyone. In this video, we will demonstrate a canteen management system that uses RFID RC522 and Node MCU ESP8266 to automate and streamline canteen operations. This system aims to improve efficiency, accuracy, and customer satisfaction. So let me introduce my team. I am Emmanuel Allan and joins with me Malay Kumar and Sarvajit Visagan. So before we start, let me say what are we going to cover in this presentation. First, we'll introduce what we did for this project and the objectives and the methodology we used, the hardware and software implementation, and the final demonstration of our projects, and finally conclusions. So this canteen management system is used to track our RFID and which is used to read our automatically identifies our identity using the RFID reader which we are going to use, and using that data we'll use our database to manage all those data transactions and all management stuff in this project. So let me explain the objective of our project. So in the real life scenario, this canteen management system is not so easy, and but using this RFID technology, we could easily make this process so easy and time saving. So this will include an order and pay in advance system, then customer management system from the customer viewpoint, and we'll be verifying and identifying each user using RFID. Basically, this RFID tag will be in our VAT student ID card, so this can be used for our purpose. Then we'll use this inventory management for the admin point of view. Then we'll also provide the real-time updates according to the transaction details and also some updates regarding some errors or feedbacks. And also this could also be used to automate tasks and also collect and manage data which could be used for later point. So now handing over to Malay.
Now I'll explain each and every hardware component used in our project. We have used four main components such as Arduino, Node MCU ESP8266, RFID RC522, and an LCD 16x2. So Arduino Uno has 14 digital pins, in which six are pulse wave modulation outputs and six have analog inputs. A 16 megahertz quartz crystal is used for timer and a USB connection to upload our code, reset button to reset the Arduino every time. Uh, yeah, so this we have used mainly for LCD. Then we have the Node MCU ESP8266. It is designed for Internet of Things application and supports Wi-Fi connectivity. The Node MCU ESP board has 11 digital pins and output pins, one analog input pin, and a micro USB port for programming and power supply. It can be programmed using Arduino IDE and other programming languages. The board is compatible with a wide range of sensors and modules, so we could easily interface our RFID RC522, which is a low-cost radio frequency identification device which can read and even write on the RFID. It is based on MFRC522 chip, which operates at 13.56 megahertz frequency and supports ISO and IEC 1443A MIFARE mode. The RC522 model can write and read the RFID tags and can communicate with microcontrollers through an SPI interface. And then we have LCD, which is a 16 cross 2 LCD, which will be used to display the messages that are required. And yeah, that's it. Now we have this circuit diagram in which we have interfaced LCD with Arduino and RFID with both are interfaced using serial communications. Now, Sarvajit will Sarvajit will tell you about how we reached to this.
So we've reached to the results and the work completed by us. So as you can see, here's our canteen management system, which will be later seeing in the demo also. So this consists of like data where the user reads the tag and his data can be entered or and is stored, and transactions occur, and then the transaction data is stored. All of it will be showed in the demo later. So what is this system? The system can work by providing each customer with an RFID tag that contains their information such as the name, ID, number, and account balance. When the customer visits a canteen, say, they can use the tag to make purchases without the need of any physical cash or cards. The system can also track the purchases made by each customer, allowing for accurate billing and inventory management. But there were several problems which we faced, which I would like to share now. So the first problem as we started was that with 8051, we were able to interface EM18 RFID module, but we wanted to send the data to SQL server, for which we needed a connection between the server, which can either be provided by Ethernet, or we needed a wireless means. So we switched to Arduino, but with Arduino there was issues like the Ethernet shield, which was required, was too costly and was not available at the time, and the ESP18 Wi-Fi module couldn't arrive on time, so we couldn't meet our needs with that. So then we decided to go for like ESP8266 Wi-Fi module, which had an inbuilt Wi-Fi module and a microcontroller with which we could easily interface the RC522 RFID. Now, since the to interface LCD, the pins were too less. That's why we overcame this problem by using Arduino with ESP8266 using serial communication. So yeah, so here you can see the live demo of all of our thing. Now we'll look at the demo for the project. Let's
Okay, so now I'll explain how our code works. First part, we'll explain how we did our database, connected our database, and did our web browser using PHP and MySQL. So this is our home page, and we did this in our home.php. This is just a introduction page for our site. Then we use this database.php where we have included our credentials of the database in order to connect with them, and also use necessary queries in order to get the data. In get UID, we are extracting the UID which we read from our ID card. Next, uh, talking about the registration form. So basically, if this encounters a new UID, it will ask us to register a new user. If it already exists, it asks us to register. It just shows by querying. So this is the form where we are getting the data from a user. Uh, then this is the form where we are displaying if a user exists, and this is where we read the data tag. Then next part is a user table where we are displaying all the users present currently registered. So using this, we are just querying all the necessary users who are logged into our canteen, and this is where we edit the user and delete the user. Using the update DB, we are updating the required username to our MySQL. So this is where we are storing our user ID. So we'll get the user ID when by scanning, then save it in a file. So to display this, the user's data, we are using read tag PHP. So when for the transaction, we'll ask the user to enter the item name and the price. And in this transaction PHP, we are getting the data. Then when the user submit the form, we'll use this transact SQL in like the query, and we'll increment the date amount for the canteen manager, and we'll decrement the amount for the user, that's the customer. And here we are displaying the all the transaction history, and for that purpose we are using transaction.history.php. Now Malay will explain the Arduino code.
Now in this section we will have the code explanation. This is the code for the ESP8266 microcontroller, which will use an RFID to read the data from an RFID card and send the data to a server via an HTTP request. Then we'll have four libraries. First library, ESP8266 web server, to create a web server on the ESP8266 board. And then we have an HTTP client to make HTTP requests. And then we have SPI for serial peripheral interface protocol for RFID communication. Then we have MFRC522 library for controlling the RFID reader. Then we have some global variables and defining the pins. So first is SS pin. SS pin acts as a signal input when SPI interface is enabled, as serial data when the I2C interface is enabled, and as serial data input when the UART interface is enabled. So then we have this reset pin. Reset pin supplies for power down and reset. And then we have then we'll initialize the pins and declare in the MF RC522 class. And then we have the a client instance for Wi-Fi client, and then we have onboard LED pin. So then we'll start the server using 80 port on port 80, and then we have SSID and password for connecting to the local host. And then and then these are the some of the variables we'll be using. Then we'll set up, like first we'll set up the serial communication. So we'll at the baud rate of 9600, and then we'll begin the serial peripheral interface. Then we'll initialize the RC50 522 board, and then we'll start connecting to our local host using the SSID and password given. And then as soon as it gets connected, we'll have an indication on the board. And then and then yeah. And then we have the loop section, in which first we'll try to get the ID from a RFID card, and then if the read is successful, it will be indicated on the board. And then we will make an HTTP request to the client, which will be our canteen management system's website. And then we'll post this whole data, like that will contain the UID of the RFID onto that server, and we'll also print all the details on the serial monitor. So to get the ID, we'll first check if the card is new or if it's an old card. If it's a new card, then we won't be able to read because nothing will be written on it. And then if the card is perfect, uh, then we'll have the UID and we'll read, and then we need to convert that hex values into ASCII, and then we'll convert it to a string. So to convert, we'll convert that array to a string, and as well as we'll convert it to uh, ASCII, and then we can pass it to the web server. Now in this code, since there were very less pins on ESP8266 board, and we wanted to connect an LCD, so we serially connected Arduino Uno board and ESP8266 board through serial communication. So that if anything which is serially communicated on the ESP8266 board will also be reflected on the Arduino Uno board. So here we have this liquid crystal library for initializing our LCD. We have the contrast value 25, and then we have the pin definitions. So here we have 4 data pins, and then we have pin 11 for register select, which will toggle between command and data register, and then we have 12th pin for RW, which is like toggle between the read and write operation. And then we'll set up, so first we'll set up the serial communication, then we'll write the contrast through the this 6th pin is for VO to write the contrast value. And then then we'll start the LCD. First, we are printing just Canteen Management System project, CMS, and then we are setting the cursor to print it on the LCD, and then we have then anything that will be serially transmitted, we need to convert it to string because it will be transmitted as bytes. So then we'll convert it to string, and then we'll print on the serial port as well as on the second line of the LCD. So here we are printing on the second line whatever which is transmitted through the ESP8266 port. That's
In this section, we will demonstrate a canteen management system that uses RFID RC522 and a Node MCU ESP8266 to automate and streamline canteen operations. This system aims to improve efficiency, accuracy, and customer satisfaction. So the overview of the system goes as follows. The system consists of an RFID reader module, a Node MCU ESP8266 microcontroller, and an LCD display module. Customers are provided with RFID tags that contain their information which can be used to make purchases without the need of cash or physical cards. The system automatically updates the customer's account balance and tracks their purchases for accurate billing. So now let's begin with the demonstration. Here we have an RFID reader connected to the Node MCU ESP8266 microcontroller. We also have an LCD display that displays the message tap card and also displays the unique ID stored in the RFID. Now when a customer approaches the canteen, they can scan their RFID tag on the reader module and their information will be displayed on the website. So let's see. Now if I scan this card, it will get displayed on the website. Okay, now if I scan some another card, it shows an error that this ID card is not yet registered. So we'll register this ID card now. To register the ID card, again tap the card, fill the other details. And we'll give the initial balance amount. And then we'll just save the card, and then it will be stored in our user database. Now suppose the customer can then select the food item they want to purchase, and then corresponding prices will be deducted from their account balance as soon as they tap their card to pay. So we'll go to transaction, we'll give the item name, we'll give the purchase amount, and then we'll scan the card to tap. So yeah, now it is paid and it is updated in the transaction table. So, and that's it. So the canteen management system, as you could see, use RFID RC522 and a Node MCU ESP8266, and this offered an automated, streamlined, and efficient solution for canteen operations. The system improves customer experience by providing a convenient payment method and ensuring sufficient supplies of food items.
Thank you for watching. Hope you guys liked it.